So oblique asymptotes and point of discontinuity. So we're going to look at the key concept. So the key concept. So if f of x is equal to ax divided by b of x, where these are polynomials and they cannot be factored or cancelled, so there'll be no common factors for both of them, and b is not equal to 0. So let's have an example. So if we have f of x is equal to x to the 4 3x cubed divided by x cubed minus 1. So we haven't got any common factors on the numerator and denominator, so these won't simplify. And then we're going to look at our degree. So we have x to the power 4 and x to the power 3. So when the degree is higher on the numerator, we know that there is no horizontal asymptote. But if the degree, so when the degree is higher on the numerator and has a difference of 1, so when this is the case, we will have an oblique asymptote. And we need to find the equation for the oblique asymptote. So what we do, first of all, we're going to graph this, but we're going to find the vertical asymptote. So I'm going to call it VA for short. So this is when we set the denominator equal to 0. So x is equal to 1. And then we've got, this is x cubed. So we've got 3x is equal to 1. So if we have a look at Desmos, so let's minimize that. So you put the graph into Desmos and it's going to look something like this. And then what we need to do is add, so x is equal to 1. So this is our asymptote here, this purple line. So we have an oblique asymptote. So we need to find the equation of this line that's going to take us here. So to find the equation of the oblique asymptote, we need to take the equation and it says x4 plus 3x cubed divided by. So we're going to do long division. So by long division, okay, sometimes you can use synthetic division, but that only when you have a degree of 1. So let's do this. So we'll have x3 minus 1. We need to divide this into x4 plus 3x cubed. So to do that, so this is going to go into this x times, and x times x cubed is x to the 4. And then x times minus 1 is going to be minus x. I'm going to just write this over here. So now we're going to minus, so if x4 minus x4, so that's just going to be 0. And I'm going to bring down the 3x cubed, and I've got minus x. So x goes into 3x cubed, x cubed goes into 3x cubed plus 3 times. 3 times x cubed is 3x cubed, and 3 times that is minus 3. So that cancels us 0, and then we've got minus x minus 3. So x cubed minus 1 is not going to go into that. So this is going to be our equation of the line. We can ignore the remainder. So let's go back to Desmos. And we can type in here y is equal to x plus 3. So changing that to green, just so we can see. So here we have our oblique asymptote on the equation of y is x plus 3. Okay, so looking at another example, so we have 3a and 3b. So we need to graph each function. So the first thing we look at is the degrees. So this has got a top heavy, so it's higher on the numerator, and there's a difference of 1, which tells us there will be an oblique asymptote. We know that there is going to be a vertical asymptote. So the vertical asymptote, let's do that first. X minus 2, we set that to 0. So this is x is equal to 2, the denominator. So when it's a degree is higher on the numerator, there is no horizontal asymptote. So there's no. But if the degree, the difference is 1, there will be an oblique asymptote. So I'm going to call it OA for short. And we need to find the equation. So we're going to use long division to find the equation. So let's do that. So x minus 2 divides into x squared. So x goes into x squared, x times x squared. X times x is x squared. X times minus 2 is minus 2x. And we're going to minus them so we can, so when we minus, we'll get 0. Okay, so let's have a look at the next one. So this is 0. So we got plus 0. So 0 minus minus 2 becomes plus 2x. So how many times is x going to 2x? So this is going to be plus 2. So we can ignore the remainder. So we have x plus 2. And this is going to be our equation of the line. So put in the equation into Desmos. And we've said that we're going to have a vertical asymptote at x is equal to 2, which looks right. And then our oblique asymptote is going to be at the line y is equal to x plus 2. And we can see this is also correct. Okay, so we're going to have a look at 3b. Okay, so let's have a look at 3b. So the first thing we need to do is compare our degrees. So it's higher on the numerator. So we know that there's no horizontal asymptote. And the difference is 1. So there's going to be an oblique asymptote. So first of all, let's work at the vertical asymptote. So the vertical is x squared minus 4. So we're going to set this equal to 0. So x squared is 4. Take the square root of both sides. So we'll have x is equal to plus or minus 2. So we can have 2 vertical asymptotes. Now there's not going to be a horizontal, but we will have an oblique. And we need to find the equation of the oblique asymptote. So we do this with long division. So we're going to divide. So we've got x squared minus 4. We're going to divide this into x cubed minus 1. So we're going to multiply by x to get x cubed, and then x multiplied by minus 4. So x times this is going to be x cubed, and x times minus 4 will be minus 4x. So I'm just going to move this minus 1 across, and I'm going to put plus 0 because it's x squared plus x and then minus 1. So that's over there. So I'm going to minus these. So this is going to be 0. Minus and a minus is positive, so this is going to be plus 4x. So x squared into 4x, we're not going to do that. So our equation is just going to be y is equal to x. So let's have a look at this graph in Desmos. So we have our graph. We have our 2 vertical asymptotes, minus 2 and 2. On our oblique asymptote y equals x.